day zero best practices. The first best practice we'll enable is the endpoint learning. So this is recommend setting to provide a learning of the endpoints across the entire fabric. There have been many reported instances of mislearned IPs and subsequent black holing of traffic. This feature is available only on the second generation of leaf switches. So we'll navigate to System and System Settings, and the fabric-wide system settings will again check Info Subnet check. Click Submit. The next one we'll enable is the endpoint control IP aging policy. Tracks and ages the unused IP address on an endpoint. Tracking is performed by using the endpoint retention policy, which is configured for the bridge domain to send an ARP request and the neighbor solicitation at 75% of local endpoints aging interval. So what we're gonna navigate is the endpoint control and click enable. When no response received from an IP address, that IP address is aged out. And use the IP address that might be struck when booting. For example, Windows virtual machine does not receive a DHCP address will automatically obtain an address from 169.254.0.16 address range. Next, to enable the loop mitigation, MCP is per VLAN. So miscabling protocol, misbehaving server, external network equipment running spanning tree will error disable interface, and we cannot do, obviously can do per VLAN basis. So we navigate to Fabric and access policy, and the policy in global MCP instance by policy default or click enable, and we'll enable MCP PDU per VLAN. Submit. Okay, we'll look at it next. Loop mitigation is roles endpoint detection. This is under system setting and endpoint control. Go pick the roach EP control policy and we'll enable it. So this is only the misbehaving points is quarantined and a fault is raised to allow easy identification of problematic endpoints. If roach EP is enabled, loop detection and bridge domain move frequency will not take effect. The range of valid values of roach EP detection are visible from the UI. It is possible to configure values out of a valid range via a REST calls, or it will cause a fault. Roach EP detection works within a site, and the feature is not designated for frequently moving EPS between sites. Next, we'll take a look at the system and system setting, and here we'll find a pod tracking. The pod tracking, I'll turn it on. This pod tracking is a fabric pod tracking addresses as a scenario where leaf nodes that may lose connectivity to all spine nodes in the ACI fabric. It detects the loss of fabric connectivity on a leaf node and brings down the host facing ports. This allows the host to fail over to the second link to the spine. For most server deployments, server should be dual horned and port tracking should always be enabled. Next, we'll go to global AES passphrase encryption settings. We'll check it out, give a passphrase. These encrypts the username password in a backup. If you don't have encryption, turn it on and your backup, the username and password are blacked out. When you try to restore from an unencrypted backup, the password will not be there. They will into a lower line default 63 for ISIS metric. We'll navigate to the system, still the system settings, and ISIS policy. By default, it just changed to 63. We don't want to change. Ensures that when a new spine is introduced in booting, for example, or during upgrades, reboot of spine, the spine is not in the path, or we're going to say the forwarding to external destinations until the full configuration of the spine is completed and default metric is changed to a lower metric. Next, we'll take a look at the system and system setting and COOP group. We have two big groups right here. We change the is introduced an attribute to use for MD5 passwords. And attributes in this manager object we call token is a string that changes every hour. Second type will allow MD5 authentication DMQ connections, which we enable for increased fabric security. So next time, let's take a look at my fabric inventory, inherit onboard 2 spine and 2 leaf. What I give them is the OOB management interface. Under management tenant, we're going to navigate to the nodes, manage the address. For the nodes, and I have a leaf. These the leaves OOB subnets, and the spine we're given the same IP address range. And go back to the system, we have given a UDC time, date and time. What I've done, another one is the fabric. On the fabric, we have the policies. Under fabric policies, we're gonna have the policies here. And we'll have the pot date and time. Pick default. You have introduced an NTP server right here. What we're gonna do, we're going to the pods under policy group. We'll create the pod 1 policy group. DM time, I've chosen default. And under profile default, I'm picking up this pass policy group policy. Per VPC virtual channel connection. In this diagram, we have a port 11, port 12 on both leaf 101, 102. My leaf 1 and leaf 2 will connected is virtual UCS connection to the FIs. They will be port channel, and of course in the leaf is gonna be a virtual port channel. We'll go first navigate to access policy under fabric and open the switches. We're gonna create is the policy, and we'll move down to virtual port channel default. We're gonna create a VPC explicit production group. We're gonna VPC leave 11 to 102. Give well, VPC number. Switch 1, switch 2, submit. And we'll move to close this, move to interface. We'll have create the interface link level is gonna be 10 gig, and we're gonna repeat, or I will repeat it to create the CDP interface policy, CDP on and then CDP off. And I have this LADP on and off. Also, I will need the port channel. Port channel, I have one, just one for LSP active, and MAC pinning. This to one of port channel policy, interface policy I've created. Next, I will go to policy. Under global, it will have attached access entity profile AP. We're gonna create a new one. We're gonna create UC as AEP. Click next and finish. Next, we'll configure VPC policy group. VPC policy group is under the interface, leave interface, policy group, VPC interface. I created one for UCS FIA. These are the policy group for fabric interconnection A and interconnection B. After that, we are going to create leaf interface profile to specific Ethernet interface for the VPC. So navigate to the profile. We're going to create a leaf interface profile. I'm going to say leaf 101, 102, interface profile. I'm going to add to the port is 11. It's going to be 1, 1, 1. Click OK. And we'll create the port 12. Submit. So what's the next we're going to create is the switch leaf profile and select leaf switch that belong to the VPC domain. We'll navigate to switches and profile, new leaf profile, leaf 101, 102, switch profile. Gonna add choose all leaf switch. Click next. We're gonna associate with our interface selector profiles. And click finish. Now we have the switch profile with interface selector. That's the VPC route down here. Configuration will make tenant configuration. First, we're going to create a security domain and a tenant user. Navigate to a domain and AAA under security and the security domain. We're going to create a new security domain. We'll call it 10, 10 and 2. Submit. So we'll create the security domain to apply the user account and the tenant. I'll create a tenant user account and associate it to the tenant 2 security domain. Under user, we're going to create user ID, T2 user. Click next. We'll choose security domain tenant 2. And roles, we'll make admin and write update. Click finish. While we're logging as an admin to the Epic Simulator, we'll create a tenant. So go to tenant, add a tenant. We're gonna make 10 and then 2. Security domain we'll pick is the tenant 2. Update VRF. We're creating VRF1. Click submit. Now we have a tenant 2 tenant. I will do a logout and logging as T2 user. What I see is only the tenants, or I have only one tenant 2. So first of all, take a look at the networking. We only have VRF created. We're going to drag a bridge domain here, and we'll say it is our web bridge domain. Under L3 configuration, make sure is I'm going to add a subnet. So the subnet, so we're going to make it 192.168.10.1/24, and that'll be it. I'll click OK. This will be the pirates to the VF. Make OK. Now we have the bridge domain called web. We'll repeat the process or drag to the VF. We'll create another bridge domain called app. L3 configuration, add a subnet to it. It's going to be 192.168.11.1/24. Click OK. Click OK. Now this time is we have created the app and a web bridge domains. So we're gonna open enable the ARP flooding is default disabled by default. The assumption is the hosts are not silenced and the will source frames, allowing the leaf to learn and the endpoint. The later lab will create SVI to connect the switch to an endpoint. It's a bare metal server and will communicate with the app servers. The SVI will not be the source traffic, so the fabric will not learn SVI IP interface. So with ARP flooding disabled, the unicast routing is performed on the target's address. In our scenario, the SVI is not sending traffic, so the host route is not in the routing table and ARP is dropped. By turning on ARP flooding, the ARP request is sent out the interface towards the switch, and when the ARP response return, the fabric dynamically learn about the SVI. So we enable ARP flooding on APP bridge domain. So under the networking and go to bridge domains and app, I'm gonna go to the policy. and go down here. We have one called ARP flooding. Submit the change. And the same for the web. Okay, submit. Gonna check again. ARP flooding is enabled. Also, we wanted to log into our Epic simulator. We're gonna show tenant2 bridge domain, and we'll better see it showed again. We have two bridge domains under tenant2. ARP flooding is enabled. ARP flooding for the web is also enabled. Now the next task will create an application profile using the following task. We'll create the web and app filters. So create a web contract, app contract, and bridge contract with subject accordingly. So under tenant and move on to contract. The contract has filters. We're first to create filters. The filters we can call is the web filters. We're going to add is HTTP. It's going to be IP, TCP. From port is going to be HTTP. Click update, and we'll have HTTPS, IP, TCP, HTTPS. That's all the app will be filtered. For the contract, click submit. The next feature we're going to create for general use is the app filters. The app filters we're gonna to first name is Kerbals. Kerbals, we use IP, TCP ports is 88. Update. We create Kerbals so we create a shrink wrap. It will be our IP, TCP 358, click update. So we're creating Kerbals and a simple wrap for app filters. Click submit. Now two filters are created, app filter, web filters. We're gonna to create a review contract. It's gonna be contract. Create the contract name. It will be gonna be web subject. So go back. It will be web contract. Subject. We're gonna web subject. We're gonna to move on down here. We're gonna pick the web filter and actions permits, and also we wanted to allow ICMP. Okay, submit. Now I have web contract. Now next, what we're gonna do is we'll have the app contract. App subject. We're gonna have this the app filters permit, and we're allowing ping. So two contract created. Both has the filters in the subject, and we'll be using our ending to ending contract. So we're gonna make ending to ending. This time we're gonna just pick up that ending to ending and subject name will make a default for future and submit. For that, we have three subject. Sorry, I'm gonna remove this contract, and training actually is gonna be our DB contract, and DB contract going to use any to any subject. Pretty easy. Now we're creating a application profile. Application, I'll just use POC. In here, we're gonna make it the EPG web bridge domain, and web is providing, of course, web is providing web contract. Will consume the app contract update, submit, go through the network. Sorry, to network. Go to POC, and the topology we are seeing is a web contract is gonna consume the app contract is providing web contract. And on the EPG, I have already created a web. So we're manually creating next one is the app EPG bridge domain app. Okay, finish. And DB EPG bridge domain is default. So three EPG created. Go back to a POC topology, creating three EPG owning web EPGs providing and consuming the contract. So we'll make the other line connected. For the app contract, we're gonna to right click it. We are gonna to provide our app contract, and we're gonna consume the DB contract. For the DB contract, we're only gonna to provide the DB contract, which is any to any. Now go back to topology. If you can see it, we have other lines connected. Web app, they are all providing their own contract, and DB also DB contract. The consuming is the apps consuming the database, web is consuming the app contract.